This is the workbench of K&H pneumatic chaining system. For doing experiment, the user needs an extra air compressor to work with our system. Our trolley is two-sided. There is a door. When we open it, we can see the chest of drawers of the opposite side. At your right hand, firstly, we have a glide table for putting your laptop or exercise manuals. Below, there are 4 drawers. It's for the storage of pneumatic components. For the working place, we use grooved plate. All our components are designed for it. Just push the 2 sides of components slightly and then mount it on. You can see it's well fixed. For taking it off, push again like this way. At the top of trolley is the control panel of PLC. They are time-relayed, signal input switch, relay, digital counter unit. So it facilitates the exercise of students. At the rear of trolley, we see the same design idea. Here we see the chest of drawer of the opposite side. At your right hand, there are drawers too for putting the pneumatic components on. For working place is the same grooved plate. It means 2 groups of students can work together with this trolley. Now we are going to see some experiments. The first experiment is air cylinder moving forward by manual control and reversing by pressure control. Firstly, we need air service unit, then 3-way distributor, 3-pole 2-position push-button valve, 3-pole 2-position lower level valve, 5-pole 2-position double-acting pneumatic valve, pressure sequence valve, and at last, pneumatic double-acting cylinder. Now we are going to show you how to connect those components in this exercise. Put the air service unit on the groovy plate. And also other components. For connection, firstly we connect the air compressor with the air service unit by a tube. Here, we can control the pressure of the whole system. We can see the value of pressure here. And there are 6 ports for the output of air pressure. All our system adapts faster plug-in connector. Just put it in like this way. For taking it off, push and pull the tube out. Now we connect this port to push button valve. Another air pressure source to double acting pneumatic valve. And then connection to lower level valve. Now we finish the tube connection for introducing air pressure to the system. The connection of this exercise is done. The air pressure passes through push button valve, then double acting pneumatic valve. In this component, when air pressure comes from the right side, it will go through P to B port. If from the left side, it goes through P to A port. The pressure from A and B port can control the cylinder to move forward or to move back. After pneumatic cylinder, we install a lower level valve. This valve is connected to a pressure sequence valve. When the system's pressure is higher than the setup pressure here, it will function, otherwise not. Now we can see how the system functions. Firstly, introduce air pressure in the circuit. Adjust the pressure to 3 kg. Push it down and turn this switch on. Whole system is full of pressure now. So when we push the button here, the cylinder will move forward and start the lower level valve. When lower level valve is started, the air pressure returns to the second valve. We can use this connector to set the pressure here. When the pressure decreases, the cylinder will move back to the initial position. It means now the system pressure is 3 kg and here we adjust to 2 kg. So air pressure will pass through, then the pneumatic cylinder will move back. But if here we adjust and do it again, you see the cylinder doesn't move to initial position because the pressure of sequence valve is higher than system pressure. So we can adjust the system pressure to 5 kg, for example, higher than the pressure of sequence valve. Now the cylinder returns back to initial position. In this experiment, we learn how to control pressure sequence valve and the lower level valve. Then we are going to see another experiment. Second experiment is interlock starting on and off circuit. Components required are air service unit, need to be connected to air compressor, 3-pole and 2-position push button valve, 2 of 5 poles 2-position double acting pneumatic valve, 3-pole 2-position lower level valve, 2 of 3-pole 2-position one-way lower level valve. At last, we need 2 of pneumatic double-acting cylinder. Now we can put all components on the groovy plate and connect them by tubes. The connection of this exercise is done. In this experiment, we have two cylinders, first one and second one. When the first one moves forward, it will touch the lower level valve and make the second one move forward also. When the second one moves forward, it will touch another lower level valve and make himself returning back. When returning back, it will touch another lower level valve and make the first cylinder returning back. It's a one-way lower level valve here. Only touched by one side will start the movement, the opposite side not. Let's see how it functions. We adjust the system pressure to 4 kg and switch it on. The system is full of pressure. Push the button. The first cylinder will go forward, then the second cylinder also. Let's see again. Then, if we adjust the system pressure to only 1 kg, the system functions more slowly. It will be easier for the observation. We see the first cylinder touch lower level valve and the second cylinder start to move. In fact, those actions are controlled by those two double-acting pneumatic valves. When the pressure comes from the right side, it will go through from P to B pole, and the first cylinder will move forward. When it moves forward, it will touch another lower level valve. The pressure will go through from P to B pole. So the second cylinder will move forward also. When the second one moves forward, it will touch the lower level valve here. So the pressure will go from P pole to A pole, will make himself returning back. At last, when the second one turns back, it will touch another valve. So the first cylinder will turn back. Let's see again the movement. This is our experiment of a sequence circuit.